have identified 3 4 journals.
Hi everyone, very good morning. Am I audible to all of you?
Yeah, it's audible. Welcome, Bibul Kumar.
Thank you, thanks a lot, ma'am. Okay, my voice is very clear, right?
Clear, sir. Good
Okay,
morning.
that's great.
Good morning to everyone. Due to some technical problem, sorry for the delay. I'm happy to welcome all the participants on the fourth day of the AECT sponsored 2-week faculty development program on cutting edge trends in deep learning approaches. I'm also delighted to welcome Bihil Kumar Sahi, corporate trainer and CTO, the Gimli Technical Lab. He was experienced in the field of IoT, blockchain, artificial intelligence, and Android app development for more than 5 years. And also, he was expertise in Python or Spark, Hadoop, and he also experienced in Tableau, TensorFlow.
Okay,
Today, here is there with us to share his expertise in. Hope all the participants will get the in-depth knowledge in this topic and also enjoy this session. Thank you. Now I hand over the session to Bihil Kumar, sir.
okay. Thanks a lot, ma'am. Hello to everyone, and very good morning. Uh, Sorry, like we are a little delayed, and your session, like I'm taking your session today, like because Amit sir is having some technical issues and internet issues are there. Okay, so as I discussed, he had covered till theory of regression, isn't it? Just let me know, like according to that, I will proceed. I will continue my session. Theory of regression is done, isn't it? Anyone can respond.
Yes, sir.
Okay, so the deployment, or you can say the application thing, has not been done till now. The programming of regression has not been done till now, right?
Yes, yes, sir. Yes.
Okay, so we'll continue from that part only. Now let me share my screen. Okay, I hope my screen is visible to all of you, right?
Yeah, it's visible.
Okay, that's great. So, for programming, for coding, I'm going to use Colab. Okay, are you using Colab or the Anaconda? What programming interface are you using? Anaconda or
Collab,
Colab? Okay,
collab,
that's great.
collab, collab.
That's okay. Perfect, perfect. Okay, so uh, you know how to continue. Just file and new notebook. Correct. It will be your notebook. It will be your interface where we usually code. Okay. First of all, before starting the coding or before starting the practical of regression, I know you had already gone through the theoretical part, but first of all, just I will give you a little insights like why we need regression. We need regression in case we have to predict a continuous value, that we are already knowing it, right? That means there is certain kind of like sales predictions are there, profit or loss predictions are there, okay, stock value predictions are there, where you have to predict a continuous value. It can be anything like 5, 6, 7, 100.2, 200.3. In those cases we use regression. Okay, now if you talk about regression, so what we do, we generally talk about basically there are two different kinds of regression we talk about: linear or non-linear, isn't it? Linear means what? It's like if you are having a data means what? Data means information. Okay, for example, if I will define something like this, okay, okay, like x is equal to np dot array, correct? Certain value, let me define 3.4, 4.4, 5, 6, 8. It's a x. The same way, let me define y. With the array we need to define it within a square bracket. Np dot array. 2, 4.3, 6, 7.3, 8. Okay, certain this random value I have defined. Okay, so here I am considering x as my feature and y is my label. That means x is my what? X is my, you can say, independent values and y is my dependent values, isn't it? Now what we want, we would just want to figure out like how x and y are correlated to each other. What is the relationship between x and y? Okay, so that is what we have to figure out. Okay, and that is called machine learning. That is what a machine learns and figure out the relations between the input feature and the output value, right? So how can we figure out? Okay, so it's like, first of all, let me plot it. Okay, so for plotting I will use matplotlib. Okay, x comma y. Okay, so it is what we are having. Okay, so it is a case where x axis is representing my feature and y axis is representing my label. Okay, now if I will ask you that, can you tell me what will be the output if my input is 4.9? If my input is 4.9, can you tell me what will be the output? Obviously you can't tell, because there is no linear relationship, there is nothing like that. Like it is not like 2 cross 2 equal to 4, 2 cross 3 equal to 6, 2 cross 4 is equal to 8. It is not a relation like that. Okay, where you can easily define, if it is 2 cross x is equal to 10, then what is the value of x? You can say the value of x will be 5, isn't it? You can easily define in that case, because that is following a pattern. But here there is no pattern. Okay, there is no predefined pattern. Okay, it is just like some random points are there which is distributed in this universe. Okay, now we have to define what we just need to define a linear or a non-linear reference line, okay, that can best represent this data. That is how your linear regression works. Correct? A best fit line, or you can say a reference line that can best represents this data. Okay, now question is, how can we do it? Correct. So for doing it, what we will do, we will start from any random position. Okay, what we will do, we'll just choose any random position. What I mean, just a minute. I mean, we will start from some random position like this. Okay, anything. Okay, anything, whatever that suits me, I will just start from that. Okay, I consider this is my best fit line. Okay, what I do, I consider this thing as my best fit line. I will say this is my best fit line. Okay, this is my best fit line. Now what happened, when I consider this thing as my best fit line, I will figure out the errors, what this best fit line is having, the error this best fit line is having, isn't it? What is the error this best fit line is having? Okay, what is the error that best fit line is containing? Okay, so and thereafter, after figuring out the error, okay, once we figured out the error, what we do, we try to decrease the error to a least possible values. We'll continuously try to decrease the error to the least possible values. This is going to be our approach. Correct. And please do take your, this is very important approach, because it is the approach that is used from basic to the advanced level, from the very basic of machine learning to the advanced level of deep learning and neural network. Okay, so that is what we have to do over here. So how can we do it? It's very simple. First of all, look here. First of all, we are going to discuss linear regression, then we will discuss non-linear and all. Linear regression, we know anyhow we will get a linear line which will start from negative infinity to positive infinity. Okay, there is no boundary for it, but there must be a slope of it. Okay, every linear line is having a slope, and every linear line is having something that is called intercept. Okay, through this slope and intercept only any linear line basically defined. Okay, that is what we know. Correct. So what we do, we will just define some random slope and intercept of this linear line, right? So how will we do it? It would be like this. Just define any random slope. W is equal to, I define 3. Okay, intercept I is equal to, I am just defining, or C you can say, C is equal to 4. Correct. So if you have defined this thing, then y, okay, y you had already defined over here, y h is equal to w into x plus c. Correct. W into x plus c. Okay, this will be your YH. Then what is the value of YH? Okay, these are the values of YH. Correct. So we are having what? Two things. We are having now two things. First, Y, which is actual label, and second, YH. Okay, that is we think. So when a machine will learn, what a machine will do? A machine will just try to decrease the difference between these points to a least possible value. Okay, the task of machine, the working of machine, the learning of machine will depends upon decreasing the difference between these points to a least possible value. Okay, it will try to decrease the difference between these points to a least possible value, and that is what a machine learning in case of linear regression. Correct, because there is a actual value and there is a something that you can say the predicted value, but the predicted value is not correct. Okay, so machine will try to decrease the difference between these so that a better position can be established, right? First of all, before getting into that process, let's plot again. So plt dot plot x comma yh. Okay, so as of now, this is our line. As I said earlier that we will start with some random points or some random line, and this is my random line, and we have to make it correct. We have to make a situation where this line can converts into a best fit line. Correct. Now question is how we can do it. Correct. So before doing it, we have to basically decrease the errors. So let's figure out the error. So error is equal to what? Y minus YH. This is our error. Okay, this is our error. Now error is what? Error is containing negative values as well as positive value. Okay, here all the errors are containing negative values, but in general case it will contain negative as well as positive value. Okay, now with negative and positive value, if I have to calculate the mean of it, obviously the mean will not be the actual mean. If you want to calculate the mean, what we need to do? We need to take the square of it, isn't it? So just square the error. So this is your square of error, and it is your what? Mean square error, right? It is your mean square error. Perfect. Right? Sorry. Dot mean. Okay. So it is what? It is your mean square error. Right. Now we have to decrease it. Now the question is, how are we going to decrease it? Correct. So to decrease it, what we will do? We will use certain process. Let's understand the process. Let me write the equation first. E is equal to y minus YH whole square. Just give me 1 minute. I will just add in something. Just give me 1 minute. I'll be back. Okay. Okay, so thanks for your patience. Okay, so it is our error value. Now let me write it over here. Y minus the value of yh. What is value of yh? Yx plus c. That is over here yx minus c. Correct. Now just partially differentiate error with respect to slope, that is w. Why with slope? Because here you have to change the slope only. You can't change the value of x. The values of x are fixed. Those only value, the features will be fixed. The labels are also fixed. But we have to we have to decrease the error. That means we have to bring changes in the errors. To bring changes in the errors, we have to make changes in the slopes only. Slopes or intercept. Okay. Apart from slope or intercept, other things we can't change. That's why I am partially differentiating with respect to what? With respect to slope. That means I am planning to change this value continuously. Okay, that is I am planning to tune this value. Okay, I am planning to tune this value continuously. That's why partially differentiating error with respect to this one. Thereafter, what will happen? The output will be 2 y minus, correct, multiplied by minus of x. Okay, this is what output will be there. This is what the partial derivative output, correct. And in machine learning term, this thing is known as what? Gradient. Okay, in machine learning term, this is known as what? Gradient. Correct. And the process of decreasing this gradient is known as what? Gradient descent. Okay, now if you rewrite this equation, the equation will be like this: 2 multiplied by y minus yh multiplied by minus of x. Okay, so this is how your equation will be rewritten. Now the thing is, if you see, if you are continuously changing the value of w, okay, you are continuously changing the value of w, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at the point this thing is minimum or almost equal to 0, okay, what will happen? This value will also be close to 0. At the point where this is minimum or close to 0, right, according to this complete equation, okay, this thing will also be close to 0. Okay, so whenever this is at minimum value or close to 0, that means we are at a maximum accuracy. Correct. That means we keep tuning the value of w. We keep tuning the value of w. This value is continuously changing. As it is changing, there will be a point after some time when this thing is at a minimum value. Okay, it is close to 0. When it is close to 0, this value is also close to 0. And when this is close to 0, we figure out that we are at a minimum possible error. Correct. So how will we tune this value? We can tune this value like this: w new is equal to w old minus, correct. That means we will wait for the time, okay, when this is going to be 0 or close to 0. We'll keep waiting, we'll keep tuning w, okay, we'll keep tuning w again and again, and we will try to make sure that this is as close as possible to 0. When this thing touches the 0 figure or the closest value to the 0, what we figure out that okay, now wn and these two things, w new is same as the w old. Okay, and at that point what we say that our machine get learned. Okay, so it is the process that we are going to use. Okay, so let me apply it. Thereafter I'll take you doubts and we'll again try to figure it out. Okay, whatever the doubts will be there, I can understand the doubts will not be cleared in just one explanation, so it will take a little time, so don't worry about it. So if you understood just 50% of this concept as of now, just 50% of the concept, whatever I explained, you understood, that's enough. Okay, that's enough, because with the programming, with the further explanation, it will automatically will be easily reach up to the 100%. Don't worry about it. Okay, so let's see. Okay, So what we have to do over here, first of all, we have to calculate the gradients, right? So let's see the process how a machine is learning. First of all, calculate gradients. Okay. So how can you calculate gradients? I told you dE upon dW, right? So dEW and DEC. I'll calculate gradients for these both, dEW and DEC, right? So for dEW, the output will be 2 multiplied by y minus YH, okay, multiplied by minus of x. Okay, this is what we calculated. The same way, in case of DEC, the partial derivative will be what? Y minus YH multiplied by minus of 1. Correct? Because you know there is no x over there. It was wx minus c, minus wx minus c, right? So this is our gradient, right? So let's figure out what our gradient is having. Print dEW and print DEC. Okay, it is having 5 value because there are 5 inputs. Okay, the 5 inputs are there, that's why it is having 5 values. So what we will do, we will just sum it up. Dot sum. You can take the sum, you can take the mean, whatever you want. In both way it will work out. Okay, so it is what my gradients. Okay, 2 gradients are there. Now we have to apply, we have to use these gradients to make changes in we make changes in slopes and intercepts. So W is equal to W minus dEW, okay, and C is equal to C minus DEC. Correct? Print W comma C. Okay, so it is our new slope and intercept. So first slope intercept that we have defined, you can see this is our slope intercept that we have defined. Okay, initially, okay, because of this slope and intercept that we have defined, this is just random that comes into my mind 3 and 4 and I defined it. There is no reason for it. You can define 6, 7, you can define 1000, 2000 like that, anything. Okay, because at some point I have to start, so I just choose this real number and I choose like, okay, I will start from here. Okay, so based upon that, these are our outputs. Based upon the outputs, we calculated the differences. Okay, based upon that, YS, this is our line, linear line. Okay, and the differences, the error is this one, thereafter gradients, and this is my updated slope and intercept. Now with updated slope intercept, what we do, we will again calculate this particular thing that is called YH. Correct? We will again calculate YH. After calculating the YH, what we will do, we will figure out the errors. Again, so these are the errors. Okay, so what I told you, that error will decrease, but here error increase, and that increase also in a very ununiform way. Okay, the first error was 220, but now error is 222 and something like a phone number. Okay, so error didn't decrease, it increased in very random way. Why? In very ununiform way. Why? It happens because of this particular value, these values. Okay, you can see the gradients that we have calculated, these are not regulated. Okay, that means the first value was 3 and 4. So if you use 3 minus 822 and 4 minus 145, obviously you will get a very, you can say, the ununiform value. That is not good for the health of this learning, isn't it? So that means it is not suitable for your learning, right? So what we do, but at the same point of time, if you will use 3 minus 0.8 and 4 minus 0.1, that may suit your learning, that may helps your machine to learn in a proper way, because here the value will change in a very small portion. Okay, here it will change like from 3 it is changing to minus something. Okay, all of a sudden it is jumping from 1.2 or some very negative random values. Okay, very negative kind of high value. Okay, but here it will be very small change, and it may be a regulated learning. Okay, and to regulate the learning, what we do, we can use something that is called learning rate. Learning rate means what? The speed of learning. The learning should not be very fast and should not be very slow. Okay, if it is very slow, it will consume maximum of your resources. Okay, maximum of your resources will be consumed. If it is very fast, it can't let you, it will not it will not give you a path to a minimum possible error easily. Okay, if it is very fast, it will not give you a point of minimum possible error easily, right? That's why we have to regulate it. And how can we regulate? We can regulate with the help of learning rate. So let's see how can we use learning rate. To use learning rate, what we will do, okay, just a minute. Okay, to use learning rate, what we will do, we will use over here LR is equal to 0.001. That's it. And here we will use LR multiplied by this thing, and then LR multiplied by this thing. Okay, perfect. And here also we can use LR, that is learning rate, and here also learning rate. Perfect. Okay, so this process I will start from the very first line. Okay, so that there should be no any problem. This is your initial definition. Proper. Okay, update. So from 3, slope changes to 2.1 and intercept changes from 4 to 3.8. That's better. And our error changes from, you can see earlier it was 222. Okay, the first error that we had calculated was 220. Okay, this 220 degrades to 102. Okay, that means ultimately our errors values are decreasing, isn't it? So let's see again. Now second iteration, in the second iteration, this is our value. Okay, and it degrade down to 48. That means our error value is decreasing continuously. Correct? Let's do one thing. Okay, create a loop for I in range 50. Okay, and put all the things within it. That means, so first of all, put how are you calculating the output, the formula for calculating the output, the equation that you have decided. Okay, equation, this equation you can decide of your own choice. Here I am using linear equation because I am going through a linear regression. Okay, before I will do that part, let me plot it again. Okay, just see how the plotting changes now. Okay, so you can no such difference we can see. Anyway, just a minute. So y is calculated after y gradient, calculate the gradients. Okay, and then okay, fine, it's fine, calculate the this thing. Okay, learning rate you want to define, you can define learning rate somewhere, but it is already defined earlier. But anyway, I will define over here also, so that it would be a complete algorithm. Sorry, 0 point. This is what learning rate I have defined. Let me confirm. That's fine. Okay, so this is done, and thereafter mean squared error. Okay, and thereafter print error E, as well as the iteration value I want to print. I can print I over here. Okay, and then what I do, I will start from the very first. That means I will define the data. Okay, data is defined and everything is done, and thereafter I will define the initial value of W and C. Okay, and it is plotted. Okay, and then I will not do anything. I will directly go to my algorithm, and this is the algorithm that we have defined, and then I will run it. So okay, actually I just made a mistake. It should be dot sum. No, sorry, dot mean. I should get the mean of the error, right? Okay, let me do it again. Plot it better, and then just execute my algorithm. Okay, so my error value started with the mean squared error started with the portion of 220. It came down to 100, not 2, then 148, then 48 and 23, and it continues to degrade. But after some time, it gets stable. Like it is not changing too much. Okay. So minimum possible error is what, 2.44. At this point, if you will see both the values together, okay, like y and yh. Okay, so it is what we are getting. Okay, so you can see the difference at maximum portions will be minimum. Okay, yeah, at some point it may be maximum, like at this point it is the difference is higher, but at maximum here 4.3, 5.4, okay, 6, 5.7, and if you plot the line will be a best fit line. Okay, so let's plot it. And you must be knowing regression never gives you, okay, it is a best fit line. Okay, there some can be more improvements can be there. Okay, so what we do, I will just execute it for 50 more times. Okay, and I will see if anything changes. Okay, let me execute it for 50 more times. It is actually changing. 2.19, right? Okay, let me give over here 500. Okay, it is changing actually. Still, it is changing 1.4 on. It's changing like it is getting better, right? It is getting now better. Okay, but after some time, it will get stabilized. Actually, it will not change too much. Okay, I guess it is stabilized now. Anyway, I will just try it more, 500 times more. It changes. Okay. Okay, so it is still changing. We can again execute it. That's better. Okay, 0.79. But now I guess now it's get stabilized, because after 500 iterations also it came down from 0.79 to 0.75. So I guess now it gets stabilized. Okay, now yeah, now it's stabilized, right? Now just check the output. Okay, it is the output, and then you can see the best fit line. Much better, correct? So you had seen how the process is running. Okay, first of all, there was a random line. Then after some iterations, after 50 iterations of learning, the line, you can say the figure of line, the position of line was little bit better. Okay, then with more number of learnings, line continuously shifted its position. Okay, it is continuously tuning. Okay, why? Because the parameters are tuning. Which parameters are tuning? The slope and intercepts are tuning. Okay, and as slopes and intercepts are tuning, line is changing its orientation. It is getting better and better. Okay, and after some time it gets at its best possible position, and that is known as best fit line. Correct. If you have to understand it graphically, the situation is like this. Okay, let me explain it. First of all, just consider two coordinates. Okay, coordinate x and coordinate y. Okay, coordinate x you can consider as a coordinate that is changing the value of slope. Coordinate y you can consider as a coordinate that is changing the what? Errors. Okay, that means there is any value, for any value of w there is a value of error. Okay, for any value of w there is a value of what? Error. Okay, so you can just draw a line like this, right? Right, so after every particular number of iterations, after 500 iterations, after again 500 iterations, the errors values are changing. Okay, at some point of time the error value was over here, at some point of time the error value was over here. So what error value I need? I need an error value that is present over here, because it is what? The minimum error value. So what I am doing, I am running with the help of equation named d upon dw. Okay, change of error with respect to slope. Okay, that is partial derivative of error with respect to slope. Okay, and you know, at any on this curve at any point, if you calculate this value, what are you calculating? You are actually calculating the slope at this point, slope of this line. Correct, slope of what? This line, right? Again over here you are calculating what? You are calculating this thing. Sorry, okay, you are calculating this thing. Okay, so what are you calculating? You are calculating the slope of this line. Correct, that means the slope of line at any, the slope of line at all these points, right? The slope of line at any of these points basically affecting your parameter tuning. Okay, wn is equal to w old minus de upon dw. Okay, that means slope at this point is basically affecting your parameter tuning. At the end, when you reach at this point, the slope will be what? Almost 0. If it is 0 or close to 0, now this value will not change anymore. Okay, and when this value will not change anymore, obviously errors will not change anymore. And when errors will not change anymore, what you say? That we are at a minimum possible error, like it is happening as of now. If you see the situation, okay, if you look into the situation, it is happening over here. Errors are not changing too much. It is 0.74. Let me execute it for 500 iterations more. If I will execute it for 500 iterations more, what I'm getting? It is 0.73. Okay, that means now errors values are not changing. You can see. So when it is not changing, what you say? That we are at a minimum possible error. Okay, it is our minimum possible error, and this is our regression line. That means at any point of time, if you have to make the predictions for any particular value like this, okay, so this is your predicted value. This is what? This is our feature, unknown feature. You can say I should write uf unknown feature. Okay, this is your unknown feature. This can be your 6 point something 5. Okay, for 6.5 you draw a perpendicular, and this is our label, and it can be your something like 6.4 can be your output. Okay, obviously it will not give you the actual output, but it can give you the trend. Regression is basically meant for giving you the trends. It can't give you the exact output. Whatever the output that it is giving, the actual output will remain close to it, will always remain close to it. How much close? That depends upon the errors value. What is the error value as of now? The final error value is your, you can see, what is your final error value? This is your final 0.73. Okay, so it will be in a range of 0. Plus minus 0.73 you can consider. Okay, like that. Like 2 was the actual value, 3.15 is the value based upon the line, 4.3 is the actual value, 4.37 is the value depending on the regression line, 6 is the actual value, 5.10 is the value depending upon the line, 7.3 is the actual value, 6.3 is the value depending upon the line, 8 is the actual value, 8.75 is the value depending upon the line. Okay, so it is in this range only, around 0.73 to 0.75, plus minus 0.73 to 0.75. Okay, that is your error. Okay, so it is how your regression things works out. Okay, number of iteration depends upon the problem. There is no rule for it. Okay, there is no rule for it that how many iterations you have to run. Okay, it totally depends upon the problem. Okay, let's execute this thing again once more. So after first iteration, it is our error value 102 from 2 to 2, and thereafter it is our plot. Okay, then we decided to run it for so many times, and we decided that we'll run it for 3000 iterations. Okay, so just run it for 3000 iterations. So after 3000 iterations, the error value is 0.74. Better. These are our y and yh, and this is our plot. Apart from this, if you want to plot the error, how the error is decreasing, that also you can do. How can you do it? Okay, just do it like this. Okay, define over here one list, okay, and put the value within it, right? Apart from just using error dot append, better. Okay, and it is our final y and yh, it is your plot, and it is our error. Actually error is not looking good over here. Oh, we should append the mean of it. Please everyone mute yourself. If you have to ask anything, you can ask, otherwise you can mute yourself, right? You can check the things. Better. Oh, now it will look good. Okay, we are appending it, so I'll just tell you what exactly it will do. Just a minute. Just give me 1 minute. Okay. So there is a list which is containing all our errors values. Okay, how it is decreasing, what we will do exactly, we'll plot it. So plt dot plot range 3000 comma error plt dot so. Okay, so it is how our errors decreases. Okay, like you can see, like the first error was very high, and thereafter it decreases, and thereafter it gets constant, right? So it is how your regression works. So just let me know. I will just share this code with you, and then we'll take a real-time problem, some actual problem statement, and then we'll try to solve it. Okay, first of all, let me share this code with you. Today is what? Today the date is, let me give over here, date 19th, right? 19th. Machine learning. Better. How can I share? Is any chat? Yeah, there is a chat bot. Oops. Okay. Okay, there are some query. Laptop is about to shut down. Okay, finally. Will this Python notebook be shared? What is the tool you are using for writing the web page? What is the tool you are using for writing on the web page? Okay, for drawing, the drawing tool you are asking? Okay. Actually, this one I'm using it is some software named Sword Soft. I don't know. Like it is for the Mac. This software is for the Mac Sword Soft. Okay, so I'm using this software actually. This is your additional software. For Windows, there is something called Whiteboard. I guess I'm not sure, but I will tell you about that also for Windows. You can easily search on. There are a number of softwares are there on internet. Okay. So I have shared the notebook. Just let me know if any doubts over here. If you understood like how machine is learning, okay, what is the process behind a machine learning in case of regression, okay, you should understand it because it is a concept that is very much useful in case of machine learning as well as in case of deep learning. Okay, in case of neural network also it is very important because complete feed forward network process. Okay, while we will discuss deep learning in coming lectures or neural networks, right, we will discuss feed forward network, we will discuss backward propagation, right. So complete feed forward network and backward propagation is depending upon it, right. So you should understand it, you should know about it, right. So just let me know if it is clear for all of you or not. I have already shared the code with you in the chat window. You can just open the code and just go through it, and if you're having any doubts, please do let me know. Okay, so I hope we can continue for the next part. I guess it is clear. Okay, because you are there is no query. Still, if you get any query anytime, you can put it anytime, right? I will definitely I will feel good to answer you. So you can just ask your query anytime, right? So now let's consider some useful cases, right? So first of all, after this dummy case, I will just take a simple example and then I will take a advanced example. Okay, three stage. Basic is done. Now we are going for the intermediate level, and once intermediate will be done, then we'll go for the advanced level. Okay, we'll proceed stepwise. So just consider a intermediate level problem. So for considering the problem, we need a data, isn't it? So how can we update data? You must be knowing. Here is just process. Here is something through which you can select a data. Again, I'm telling you, in Colab, it is what? It's a folder icon. Here is a button through which you can select a data. So what I will do, I'll just go to my drive and I will just figure out some data. Just a minute. Data must be there. I've just so many things are there. Just give me 1 minute. Okay. Excuse me. Okay. So this is data, right? So this is intermediate level of data. Okay, I hope it will be easier for the beginners to understand. Okay, once it is done, thereafter we'll go for the advanced level of data things, Okay, so don't worry about it. So first of all, let me pick the data. So what data I'm using? I'm using advertising data for linear regression. Okay, advertising data for linear regression. So import df is equal to pd dot read underscore csv. Okay, advertising dot csv. Better. Tf. Okay, so it is our data. Let me do one more change. Okay, so it is our data we are having, right? So in this data, what are we having? We are having something that is known as your this thing. Okay, you can see that these things are what? These are your features, right? Features means what? Features means you can say independent variables, correct? And it is what? It is your label. Okay, label means what? Dependent variable. Okay, it is your dependent variable. Okay, so basically through regression, you can just predict, you can make a model that can predict any one value. Okay, any one value. So here we are going to use regression for the prediction of these cells. Okay, that means under certain condition what can be the cells. Okay, that means if there is a company who is planning to make expense on TV advertisement of suppose 300,000 rupees, okay, and they are planning to make expense on radio advertisement 200,000 rupees, on newspaper advertisement 100,000 rupees. So what can be, what sales value they can expect? Okay, what sales value they can expect? Correct, that is what we have to do. So how will you do it? That we, okay, first of all, just correct situation. Okay, consider a situation that company is making 5,000 rupees on TV, okay, 3,000 rupees on radio, okay, Y is for radio, and 1,000 rupees on newspaper, and made a, just a minute, and made a sales of 20,000 rupees. Okay, here X is for TV, sorry, X is for what? Is for TV, Y is for radio, okay, and Z is for what? Newspaper. Okay, now consider a case 2. Case 2 is what? Case 2, suppose company is making 10,000 rupees expense on TV, okay, 12,000 rupees on radio, okay, 6,000 rupees on newspaper, and they made an expense sales of 25,000. Okay, then company is making 15,000 rupees on TV, okay, 20,000 rupees on radio, okay, and 2,000 rupees on this one, and make a 35, okay, 1,000, right? Now it is what? There are 3 equations, right? How many equations are there? 3 equations. How many unknowns are there? 3 unknowns. And with a basic mathematical understanding, if there is 3 equation and there is 3 unknown, it is very easy to figure out these 3 unknown values. Okay, we can easily figure out what are these 3 unknown value, right, with a simple mathematical thing that we had already did in our kind of the senior secondary, and you can say class 9, 10th, 11th and 12th, right? But here the situation is different. Here the situation is not limited to 3 equations. Here the situation is how many? If number of sample is containing 200, if there are 200 samples, so there is going to be 200 equations. Okay, there is going to be 200 equations like this. Correct, if it is a linear, if we are considering linear regression. Okay, If you will consider non-linear, then it will be something different. But if you are considering linear regression, then also there is going to be 200 equations. How many equations? 200 equations. Correct. And how many unknowns? Only 3 unknowns. Correct. That means it will be like this: 230.1 x plus y plus z is equal to x plus y plus z is equal to x plus y plus z is equal to x plus y plus z is equal to, right? Okay, so equations can be more than 3. Equations can be 200, 700, 900, 1100, okay, depending upon the sample, but number of unknowns are fixed. It is 3. If you can anyhow figure out these unknowns, okay, x, y and z with minimum possible error. If x, y, z is figured out with minimum possible error, in that case those x, y, z will be used for future value prediction. That means if company has decided to make expense of 50,000, 10,000 and 5,000, and you are knowing this x, y, z value, what you can do, you can use that x over here, 10y over here plus 5z over here to figure out the sales value, or you can predict the sales value easily. Okay, you can easily predict the sales value. Okay, if this is the input that company has decided, but you have to figure out this x, y and z at minimum possible error. That is your task. Okay, and that is what linear regression will do. Okay, because this equation is representing a linear equation of mathematics, it is known as linear regression. It is known as what? Linear regression. Correct? So let's do it. Okay, so the question is, how will we do it? Look here. If there are 3 equations and 3 unknown, we can do it easily. Correct? But if there are n number of equations, then what we can do? Look here. We can rewrite this data like this: 230, 37.8, 69.2. Okay, 44.5, 39.3, 45.1, 17.2, 45.9, 69.3. Okay, 38.2, 3.7, 13.8. Correct? It is what we are having. Correct. Now there are so many, data values are there. What we will do, we will use a matrix multiplication over here. Better? Okay, it is what? It is your 200 cross 3. It is your 3 cross 1. What will be the output? 200 cross 1. Okay, right? So 22.1, 10.4, 9.3, 7.6. Correct? It is so many values are there. So ultimately, what are you getting? You are equating with actual parameter. Okay, and here is what? It's a dot multiplication, matrix dot multiplication. Okay, and if you write this equation, then after writing this equation, you have to only figure out these x, y and z at minimum possible error. Okay, you have to only figure out this x, y and z, because on both of the side LHS and RHS is known. Okay, only x, y, z is remaining. If you will do the matrix multiplication, you can easily get the equation that I had written earlier. Okay, that's why NumPy is very important in machine learning, because NumPy only helps you in creating this format of data. Okay, through NumPy only you can create a matrix. Through NumPy only you can go with a numerical Python. Through NumPy only you can create a kind of a 2-dimensional data value. Okay, a 2-dimensional data value that is called as array. Okay, that is also called as matrix. Okay, so that's why NumPy is very important in our case. Okay, in case of machine learning, right? So let's remove this part and create actual playground. Okay, so how will we proceed? We'll proceed with simple process. First of all, let me consider a easy thing. X is equal to df of tb and y is equal to df of cells. Okay, so x and y is done. Plt dot scatter x comma y, plt dot show. Sorry, I just get given over here comma. Better. Now once it is done, what we have to do? We have to plot a best fit line over here, okay, that can best represent this data. That is the role of linear regression. So how we can plot a best fit line? I said you that we can start from a random value. So just define a random value. W is equal to something called anything, like just define 5, okay, and C is equal to anything that define 4, okay, and then YH is equal to W multiplied by X plus C. Something is done at least, okay, as I said you earlier, and thereafter again plot it just to visualize what is your current situation. Okay, so it is our current situation. Okay, we have to make it better. To make it better, what we will do? We will just copy not this one. We'll just copy this algorithm. Okay, and I will paste it over here. Okay, we'll do a little change. Okay, learning rate is there, DW and all these things. Okay, before defining the learning rate, I would just want to check the gradients value, right? So I'll just paste it over here. This is our gradient value, and okay, so here capital X will be there, and here capital Y and YH. Okay, because the learning rate will depends upon the gradient value, so that's why print DEW and print DEC. Gradient and in gradient for both the things. Okay, so it's a huge gradient value, right? So what I will do, it can be 1 2 3 4 5 6 7 8. So here 10 to the power 8 will be minus 8 will be good choice. 1e minus 8. Okay, learning rate I am using 1e minus 8. Rest all the things will remain as it is. Make it just for 100 times. Here YH capital Y and here capital X. Correct. These are going to be your gradients. Better. And then W learning rate, that's fine. W and this thing has been defined. Yeah, it is defined. And thereafter errors will be what? Capital Y. That's better. Okay. So now if I execute it, I can get a better picture that how errors are decreasing after 100 number of iterations, right? So let's plot it. executed. So after 100 iterations, the error has been decreased up to 12.88. This is a mean square error that is showing over here. Okay, so let's plot it and just check the output, what changes had been made. Okay, so it is the new situation. Okay, so we had started from a situation where the line was anywhere in this world, in this universe. Okay, and now the line changes its position and now just take a position where minimum possible error is there. Okay, take a position where minimum possible error is possible, correct, with the help of continuous tuning of slope and intercept. Okay, can it be tuned more? Yeah, obviously it can be tuned more. Let's see if any change. No, it is not changing too much. Okay, it is not changing too much. Okay, so we can say that it is a best fit line. If any, from any point if you start, it is not like that you are starting from here. Suppose I am starting from 15, right, and here I am starting for 9. Okay, and then again I'm doing the same thing, right? So is it 10 to the power 8 is good? 1, 2, 3, 4, 5, 6, 7, 8. Okay, it will work out. So almost same, 11.41 after 100 iterations. Okay, almost same over here, 11.41. Okay, little bit changes are more. I will just explain. Let me try for 100 more iterations. It is not changing a lot. Okay, it is almost same, correct. If you put y and ys together, you'll get the things. Now the question is prediction. How can we make the predictions? Correct. So it is your y and yh. It will be some point. It will be close. How can you make the predictions? So for making the predictions, okay, we need two values named w and c. The final w and c. Okay, these are all final w and c. What you can do? You can just use. Suppose there is an unknown value. Unknown value for TV expense, okay, is 30,000 rupees, 30.5. So what we can do, the predictions for cell will be 30.5 multiplied by W plus C. Okay, 10. That means 10,000 or 10 lakh, 10 crore, whatever it is, the units never matters over here, but this is our predicted value. Correct. So it is how things are working out in case of this one. Okay, I will make some more changes again. I just want to try explore this part. Okay, suppose I am making over here 1 and 1. I just want to explore it more. Okay, so here the errors are more. Actually, it is not good. I am again starting over here from, suppose I am starting from 10 and 8. Okay, fine, 10.72 now. Okay, so the question is why, like when I'm starting with different values, the errors, the convergence, the minimum error is different. Why is it so? It is because, you know, whenever you are starting, this is also very important fact. Okay, whenever you are starting a error optimization, okay, So what happened? Ideally, we can say the error minimization graph goes like this. Okay, but it is not ideal condition. Always there is not ideal condition. Okay, it is not a minima means always a minimum error. Okay, the condition actually in case may present like this. So over here you can see how many minimas are there. There are three minimas. Okay, these three minima, if you consider individually, are known as local minima, but there is one global minima which is at a minimum possible value. Okay, but the case is if you start from here, how you converge at this point. If you starts from here, you will converge at this point. If you start from here, you will converge at this point. Okay, your algorithm will consider this thing as a minimum error. If you start from here, again you will converge at this point. Okay, but if you start from here, then you converge at this point, or you start from here, you will converge at this point. Okay, that's why what we do whenever we initiate some machine learning, we don't get relaxed after the first cycle. Okay, after the first cycle, we again initialize our learning from some different other points. Like first we initialize w is equal to suppose 2 or 2 and c is equal to 3. Okay, then again we initialize our learning with some other point like w is equal to 1, c is equal to 1, then w is equal to 9, c is equal to 8. Okay, w is equal to 15, c is equal to 12. Okay, like this we keep changing these values. Okay, at different cycle, in different cycles, or different kind of a process. Okay, we run our learning process for 3 to 5 times or 7 times or 10 times. Okay, and each time we try to initialize our initial value at different locations. Okay, and out of all these locations we try to figure out which is giving me the minimum possible error. Like in our case, till now we received a minimum possible error is 10.72. Okay, this is our minimum possible error, 10.72, which we are getting if we are starting the value of w and c at 10 and 8. Okay, so initial value, apart from learning it, these parameters are very important. Okay, these are called parameter tuning. Okay, so parameter tuning is one of the very important things that we should do in case of machine learning. Okay, so what are the parameter we are tuning over here? The parameter that we are tuning over here is one that is called learning rate. Okay, and second that is also we are tuning is the value of slope and intercept of best fit linear line. Slope and intercept of what? Slope and intercepts of best fit linear line. Okay, slope and intercept of best fit linear line, right? And that's thereafter we're getting a best fit things over here with minimum possible error, and this is how we can make the predictions. Correct. The file is already shared with you. You can just explore that part. Okay, now till now whatever we discussed without the use of any library. Okay, the mathematical concepts and all we discussed, the mathematical and the statistical concepts that we discussed over here. Now we have to discuss how we can use the libraries and all. For the discussion of libraries and all, we will discuss about the things that how we can do it in a easier way. Okay, so if we are going to use a library, we need first two things. First is known as your feature. Feature is what? Your x. X is containing what? The t part. Second, you need y. Y is what? Your cells. Next, we need libraries. So from sklearn dot linear model import linear regression. Okay, and then L model is equal to linear regression. Okay, so data is defined. First of all, it is our data. definitions. Okay, after that, this is your step 1, you can say. Okay, thereafter step 2, import algorithm from scikit-learn. Scikit-learn is a package, is a library that is containing all the algorithms. Okay, what is scikit-learn? Scikit-learn is a full-fledged package. It's a full-fledged library that contains all the algorithms. Correct. Then third, train your model. Step 3 is what? Train your model. How can you train? By using L model, that is your model, dot fit. Fit is a function that is used to train a model x comma y. Okay, so it is showing some error. It is showing an error. First of all, understand the error. Expected a 2-dimensional array, got 1-dimensional array, because we are using a pre-built algorithm. So pre-built algorithm needs, we need to satisfy certain condition for it. Now we can't proceed with single dimension data. We need a 2-dimension data, and for 2-dimension data, what we will do? We'll do nothing. Just use a one more brackets. Okay, like one bracket for 1 dimension, 2 brackets. If you read a value in 2 dimension, that means you are reading a value in double brackets, right? And now it will work out. Okay, so training is done. Okay, so step 1, data definition. Step 2, import the algorithm. Step 3, just fit it. Training is done. Okay, thereafter step 4, evaluate your model. How can we evaluate our model? You can evaluate anything by testing it, right? By making the prediction. Like if you have to evaluate a child who is studying, okay, like evaluating a child, how do we evaluate a child? We take examinations, we take tests, okay, and thereafter we check their test copy. The same thing we'll do over here. We'll make the predictions first. Without predictions, we can't evaluate. So for prediction, the function is dot predict. Correct? X comma, okay, dot predict x. Okay, and once the predictions will come out, we'll store this predicted value in yp, right? And thereafter we'll evaluate it. Errors is equal to y minus yp, square of error, and then mean of error. After calculating, let's print it as well. So mean of error is 10.51. It is almost same that we got. We also got almost same 10.72, around 10.72. So almost very close, right? It is not like 10.51 and then 20 point like that. So we got manually, we got a minimum error 10.72, and it is giving us the minimum error. The library is giving us the minimum error 10.5. So it is almost close. Okay. So we had also evaluated our model. Thereafter, if you want to plot, you can plot also. Okay, but plotting will again give you the same kind of output. So I'll just copy and paste it. Okay, x and y. X is TB, y is label. X and yp. Almost same output. So all the predictions will based upon this red color best fit line. Okay, all the predictions will based upon this red color best fit line. Now predicting unknown value. How can you make the predictions for unknown values? So 4 steps done. Okay, step 1, step 2, step 3, step 4. Evaluation is done. Okay, and thereafter what do you have to do? Predictions for unknown value. 5th step. Predictions for unknown input value. Okay, so suppose unknown input value is what? 45.6. Okay, so how to make predictions? Simple. L model dot predict 45.6. So it is our prediction. That means my cells will be what? 99.2 with an error of, with a mean square error of 10.51. Okay, so that is a square error. The actual error will must be very much less than that. Okay, that will be around 2 point, I guess. 10 point is 72 is the square, then actual error will be around 2.54 or 2.57. Okay, so plus minus 2.54, 2.57, that you can consider. Okay, you can calculate also mean absolute error, that is called mean absolute error. So how can you calculate mean absolute error? Okay, like this, y mean absolute error is equal to AB is absolute of y minus yp dot mean. But at around 2.54 as I told. Okay, so it is done now. Okay, what will happen? Just a minute. Mean absolute error. Right now, next what we will do? Okay, once it is done, next what we have to do? We have to make a condition. We have to just figure out a thing like how can we like we are going to multivariables. Multivariables for linear regression. Okay, multivariables we have to use. So for multivariables, what we will do? Again, we'll do the same thing. I'll just copy and paste over here. Okay, I'll just copy this thing and we'll paste it over here. Okay, and I will copy this part and we'll paste it over here. Okay, and apart from TV, I want to consider the radio also. So just use radio. Okay, so X will contain now your two variables, TV and radio. Y is containing your cells value. Okay, same linear regression and all those things are there, and then execute it, and your error value is showing what? 2.78. Okay, so the error, the mean error, which was 10.51 earlier, came down to 2.78. Okay, the mean error which was earlier 10.51, if you remember, okay, it came down to 2.78. Right, that means radio is an entity which is very important for this model. We can't ignore radio. Okay, that means sales is highly dependent upon radio and sales is highly dependent upon TV. Apart from this TV, sales is highly dependent upon what? Highly dependent upon radio. Right, now for making the predictions, what we can do, like we made the predictions over here, I'll just copy and I will paste it over here. Okay, 45.6 for TB. Let me consider 100.4 for radio. Okay, I will put it over here, 100.4. Okay, 23.88. Okay, that means now error value also decreased. The error value which was 10.51 earlier came down to 2.78. That is mean square error. Mean absolute error must be decreased much more. Okay, and the prediction value also changes, which was 9.2 when only TB was used. Now the predicted cells is 23.88. Correct. Now consider the newspaper as well. using three variables, that is TB, radio, and newspaper. Three variables now I have to consider. Correct. So how can we consider three variables? Nothing to do, just copy this thing. Paste it over here. Okay. TV, radio, and I will consider newspaper over here. Okay. X, which is containing feature X, Y, and Z. And now error is what? 2.78 again. Okay. So it means what? Earlier it was 2.78457. Now it is 2.7841. That means newspaper is an entity which is not that much important. Okay, why it is not important? Because with TB the error value was 10.51. From 10.51 it came down to 2.78. Okay, that means for radio, the TV radio is very important factors for this particular prediction. But when I added newspaper, the error value changes on third digit, 2.78457. It came down to 2.784126. So that is almost negligible change. Okay, that means what, newspaper is not the important is. So what we can say, as a data scientist, as a data analyst, as a machine learning developer, we developed a model that can make the predictions. Okay, we developed a model that can make the predictions in case of cells. Okay, as well as we analyze and figure out, we analyzed and figure out which are the features which are important for the cells. Okay, that means we can easily say we can easily recommend our stakeholders, or you can say our client, that whatever you are spending on newspaper is just going into waste, that is not very much important. Okay, the newspaper expenses are not important, so you can stop expanding on the newspaper, because the newspaper expenses are not getting reflected on the cells. Whatever expense that you are making on newspaper, they are not getting reflected in the cells, right? So over here, suppose I am using 150.3, okay, and I will add 150.3 over here. The prediction is what? Almost same, 23.79. Earlier it was 23.88. Okay, there is not that much big change. Okay, so it is how, apart from just making a model, okay, that can predict your value, that can predict your value in using the regression concept, that can make a predictions in continuous form, we can also analyze and decide which are the figure important for your model and which are the figure that are not important. So just give me 2 minutes. I just put this thing into charge. Okay, file is already shared with you. You have to just click over the link and you can access this code. First, second, just go through all the points that I have discussed. Okay, for next 10 to 12 minutes we are having a doubt discussions. So you can just put your query, any query that you want to ask, related to it, related to anything. Okay, I'll just try to explain and make the points more clear for you. If anything that you could not understood, or you understood, you just missed any kind of clarification you want, please do put your query. Okay, and just give me 1 minute. Okay, okay, plug the charger. Actually it was discharged a bit. Okay, so on what happened now? I plugged the charger. Why it is showing now that? Okay, so now you can just put your query. If anything, any doubts you're having, you can just ask. I'll try to answer. You can unmute yourself anytime and then you can ask your query. After the break, we'll go more. We will explore more. Okay. So intermediate, basic is done. Intermediate is done. Right. Now I'll go for the advanced part. Okay. We'll consider some. Okay. We'll consider some housing price data. Okay. From kaggle.com. Okay. We'll figure out something more in it, that apart from just making the predictions, how can we remove the outliers and all. Okay, we'll consider this data set. This is a data set that is containing a lot of values, like area type is there, availability, location, size, society, right? So these are all things that are present over here. Okay, total square feet, bathrooms, balcony, and at the end prices. Okay, so we have to make a model that can make the price prediction for housing data. Okay, like user is entering that, okay, he needs a 2 BHK flat and he needs around 900 square feet, he needs at least 2 bathroom, he needs balcony, he needs certain other things like location, like he needs a flat in suppose Whitefield, okay, in Bangalore. So what price he may needs to pay. So I want to develop a platform, or I am having a suppose kind of a project to develop a backend application for a platform like Magic Bricks or websites like that, which can make a predictions of price, which can make the predictions of what price. Correct. So how it can perform, how the price prediction can be done for a user. Okay, so we will just figure it out how a price prediction can be done for a user. Okay, that is what we are going to do over here. Correct, making a price prediction for the user, right? So this is what we will discuss after the break. Okay, till then, because in this there are a lot many, because basics we had already seen, intermediate we had seen how a linear regression works, what is the concept of regression and all that we had seen. Now it's time to play with the data. Okay, so we'll play with the data after the break, and we will figure out like how a real time problems or a real estate, or you can say actual problem, gets solved by your data scientist or by your machine learning developer. What are the steps that they need to take? Okay, so just go through it. If any doubts you are having, please do put your doubts, ask your query, and then we will. You can also explore this data. I am giving you the link. If you want to explore during the break time, you can also explore this data. You can speak out, you can just unmute yourself and can put your query, ask anything that you want to ask. Is the code is available for all of you? You can access the code.
Sir, which code, sir? Whatever explained by you right now, or the
This
start
code, this code,
window you have sent?
this code that
Yes.
that I just explained. Is it accessible?
Yes, yes, sir.
This 19th ML, right? If for anybody it is not accessible, please do let me know. You all of you are having a data. Okay, just let me. Can you attach a data set over here? Okay, let me send attach the data set also with you. Please do do the practicals, right? Because if you will not do the practicals, things will not, because just in this thing the theory is not there. Okay, practical is very important in uh, this part, right? Do the practical, and if any doubts you are getting in the practical, anything like any mathematical doubts, any algorithmic doubts, anything like how it is working, how errors are optimized, or what this process means, how this process runs, anything the smaller means anything from a smaller doubt to any sort of doubt, okay, you are free to ask me anytime, okay, without any hesitation. I just put a link in chat window. Okay, from that link you can download the data set as well. Okay, the data that I used, you can download the data as well. Okay, and for any kinds of doubts that is coming that you could not understood that you want to discuss, you can just ask me at any point of time. Okay. So if you have nothing, you have nothing to ask anything. So can you sign up for the break? Yeah. Can you sign up for the break, or anyone wants to discuss something?
Sure, sir, we can have a break.
Right. That's what I'm saying. We can have a break, okay? And during the break, you can just explore more things. And after the break, if you want to ask again, you can ask, right? Okay. Thank you, everyone. Thanks for your patience. We'll again join back after the break, after the lunch break, right? Take care.
Thank you so much.
Okay. Good day.
So participants kindly fill the feedback. We will meet sharply at 2 o'clock.